All right, welcome to our webinar on hydronic piping software. We are going to use a particular software tool for this. It is a free software tool that one of the pump suppliers and one of the chiller manufacturers puts out. So I'll show you how to get that as well. And I only got a few slides on here. I'm just going to show you a couple basic things. And the rest of the time, we're actually going to go to the software and just do a live project drawing and take it from there. So there's only a few slides here just to kind of get everybody on the same page with what this particular tool actually is. If you have questions as we go, type them in the chat box. I'll look over there every 10 minutes or so and see if there's any exciting questions that we can answer as a group. So this particular software package is called Hydronic System Solutions software. The company that puts the software package together is called HVAC Solution. I believe they're out of Utah or something like that. They are doing that in partnership with many organizations, both manufacturers and colleges and universities. So there's lots of folks that sponsor that software, which is why there's avenues to get it for free. The two places I know to get it for free are from your local TACO rep, pump supplier. They can get it to you, or you can download it from the Multi-Aqua website, which is a chiller manufacturer that we work with here at TEC. So that's multiaqua.com. And then real quick, when you go to that website, it looks like this. I got up on the screen here, multiaqua.com. If you scroll down on the left side over here, you'll see this picture of the software with the little disk and everything. If you click on that, it'll show you how to download it. You basically just fill in your information, and then it'll let you download the software. And I'm sure they'll send you some marketing things about their chillers and everything like that too, which you could obviously opt out of, but hopefully you like their chillers. But in any case, you just fill out some basic info and you can download the software, and away you go. This software that you get for free is not restricted on the hydronic side. HVAC Solution does put together lots of software tools as part of this package with ductwork and air handler design and all that stuff. But for the hydronic portion, everything is included. So I'll show you that in a little bit here. What you can do, all what you can do with it. So some things you can do with this software. You can do chill water systems, hot water systems. You could do radiant systems, although not the radiant floor, but the distribution for radiant. Same thing with geo. It can handle geo systems, although it doesn't do the geo ground loop. It does all the interior geohydronic systems. You can put the equipment in there: chillers, fan coils, boilers, air separators, expansion tanks, all that kind of stuff is included in there. And it's going to size these pieces of equipment for you. You'll tell it the load that you have at a fan coil, and it'll look at all of your fan coils and say, oh, well, you got that many fan coils, and this is how much BTUs each one of them needs. This is the size chiller you need. And it'll look at all your piping lengths and say, oh, you got this much length of pipe. This is the pump that you're going to need. Same with the expansion tank and so on down the line. So it's going to size all these components for you, assuming you draw everything in there correctly, right? If you put in, a piece of pipe and leave it at 0 feet of length when it's really 100 feet of length, that's going to give you a false result, obviously. So there's very limitations on what you can do. It pretty much can cover any hydronic system, any type of terminal unit, any type of source, boiler, chiller, heat exchanger, swimming pool, whatever. And you can get pretty complex with these drawings. So like this one here is a chiller that we use for a geothermal system, geothermal chiller, if you will, where you got multiple temperatures and multiple loops. We can certainly draw all that stuff out as well. And there's where we can get some additional help on this particular software. They do have a hotline, which is nice, pretty nice for free software anyway. And then they also have on their website tons of online training stuff. So their website is hvacsolution.com. And by the way, here at TEC, we own a company called HVAC Solutions with an S, two separate unrelated companies. The software one is hvacsolution.com. So go to Multi-Aqua to get the software for free, hvacsolution.com to watch online tutorials and videos if you forget how to do something in particular. All right, so what I'm going to do is I'm actually going to cut over to the actual software tool and show you that, because that's significantly more interesting than me showing you a bunch of slides to look at, right? So when you first install the software, or if you do a upgrade to download the newest software like I did the other day, when you open it up, you're going to get this first screen, which is your default project properties, stuff you can set up on here that will be defaulted over and over for everything that you do. So, for example, I have mine defaulted to be Chicago O'Hare Airport for the weather data, right? Because that's where I'm based out of. If you're based out of somewhere else, you'll pick something else. So all the data is here. You can pick it, by country, by state, by city, etc., to get the weather data. If you don't like the weather data that it's showing you, like for me it's showing 91 cooling and -6 heating. If I want to use a different number, all I have to do is uncheck that box right there, and then I could type in the weather data that I want to use for heating, cooling, as well as wet bulb and so forth. All right, but I'm just going to keep the defaults for the Chicago O'Hare Airport data. So that's that right there. If you have defaults you want to change to metric, you can do that. If you want to have some of the grid designs that I'll show you here in a minute be laid out on there, I don't particularly like the grid, so I'm going to turn it off. I find it to be annoying, but if you want to have a grid on your drawing pad, you can do that. Just a preference type thing. That's what most of these guys are going to be here on this initial project properties, default project properties. So these are all the things you can change on here. All right, we're not doing airside today, but under Hydronic, when you get this thing first, it's going to have these defaulted on, the TACO load match and the Twin T. If you don't use those in your normal designs, you can just shut those off like I did, and then they will not be defaulted on your projects. And then if you want to use them on a specific project, you can turn them back on. But by default, they would be there. Probably one of the perks of TACO being one of the sponsors of the software. So those are some of the default things that you can change under pipe. If there's specific pipe you want to default to, like this one's defaulted to copper type L, but if you want to default it to something else, like you want to do everything for whatever reason in stainless steel, you can do that, right? Or if you want to go to a different type of copper, if you want to do it with all the PEX type stuff, right, that's all in there. But I'm going to leave mine as copper. And then if there's certain sizes of pipe you don't want to use, like right now it doesn't have 3.5 inch checked because it's kind of an oddball size, and it probably costs more than 4 inch anyway, so nobody uses it, right? If there's other sizes like that you don't like using for some reason because they're not priced attractively to you in your market, you could turn those sizes off and it will not design anything with those particular sizes. The steam stuff doesn't really much matter like the airside stuff because that's not part of this particular package, but the software is expandable to include those if you want those types of things. Electrical, you can pick defaults for 60 hertz, which is what we use in the US, so it'll already be set up that way. And then if you got particular voltages that you work with a lot, you can change those here, right? Controls don't come up to play too much in this. I'll show you some of the control stuff at the end, but it doesn't come up very often. If you got specific colors you like to use, like I have mine defaulted for the pipes for heating are red, for cooling are blue, and if it's both, it's purple. But if you want a different color, you could change that stuff easily enough on your drawings. This one's pretty important, coordination file options. For whatever reason, by default, these things are not checked. So when you first start this up, usually it looks like this with nothing checked on it. So I would definitely go check these. If you don't have them checked, you actually cannot run the reports. It's the weirdest thing. They'll be grayed out and you won't be able to run them. So in here, you just got to check them, and then you can run any of the reports at the end, which is obviously the whole purpose of using the tool. Some of them are grayed out because those are part of other package add-ons that you might have. So that's why they're grayed out in this case, because they're not part of my default free package, if you will. So they're all checked on there, show you what I got. And then if you want, optional, you can go through and add the costs of things. So if I go to Piping Hydronic, I can add in my costs for copper pipe, for fittings, my labor rates, and things like that if I want to do that. I don't have mine set up that way because I'm not an estimator, but if you are doing some estimating / light engineering and you want to kind of draw the building out and then have it estimate your costs for you, you can do that. It'll take a little work at the beginning to kind of get it tweaked the way you want, but the tool can be used that way. Most of you guys have your own tools for estimating, so you probably won't be doing it that way, but if you want to, you certainly can. So I'm just going to say OK, and that's all my defaults there, right? So that's my defaults for the software. Every time I open it, it's going to use those things as a default. When I open up a project like this right here, if I want to change that, I could right-click on this screen and go to Properties, and that was before it was my default project properties. Now it says Project Properties. So these are the properties specific to this project that I'm going to work on. So, for example, I'm just going to call this Test Project Webinar, right? And then I can go through, and if I want to change something and make it different than what I had just had for my normal defaults, I can go through any one of these and change that, right? Even under Equipment Preferences, if I want to use different air temperatures, I can do that. If I want to pick certain things for my fan coils, I can do that kind of stuff on here, right? But I'm just going to leave them alone. My defaults are sufficient for what we're going to do today. All right, so now it tells me in the top left here, this is my my test project. Most of your normal Windows menu commands are applicable, and you can do all the right type clicking with your mouse, and we'll do some more of that later on when we talk about flipping drawings and adding annotations to it, right? So the right click of the mouse on the white screen is going to get you a lot more information, just like it does in any software program. The wheel on your mouse you can use to zoom stuff in if you like, right? Let me get rid of my GoToMeeting thing. I can use that to zoom in and blow things up so I can see it a little bit better. All right, so now we're going to draw a simple project. For today's purposes, with the time that we have, we're not going to, draw a 30-story skyscraper. We'll draw a simple, residential-sized system. Or actually, we can do a commercial system with just hardly any air handlers on it, right? That'll be pretty quick to draw. Either way. So normally when we draw these systems, the way I like to do it is I like to start with a load, just kind of like the way you would design it, right? You don't start by saying I'm going to put in a 2 million BTU boiler if you don't know what any of the loads are, right? So you start by calculating a load, room by room, and then deciding in that room, how am I going to distribute the energy? Am I putting a fan coil in? Am I putting radiators in? Is it going to be PEX in the floor? What am I doing? So if you look across here, I got my normal, Windows type icons here, and we'll go through some of those in a little bit. But I also got these other ones here that say Wizard, Air Handler, Rooftop, Space, Duct, Airflow, Hydronic, and mine's defaulted on Hydronic, right? Hydronic pipe, and then some steam stuff. If I go over to, say, the duct system, I'm going to have a limited amount of things available to me, and most of it's going to be grayed out. If I go to air handlers, a lot of it will be grayed out on me. But Hydronic, everything's completely live, and hydronic pipe accessories are completely live. And then when I go to steam, a lot of these options are not going to be available to me either, depending on which version of you have. So to get the free version off the website I showed you, hydronic and hydronic piping are completely available to you, every single item in there. So then the way it works below that, once I pick hydronic, I got all these icons across here. So this first group of icons, and if you hold your mouse over it and hover it, it tells you what it is. So here's my different boiler choices, right? I could pick them by brand if I want to, and these are obviously manufacturers who have partnered with the software supplier, right? And then if I want to pick something generic, that's totally fine too. I can pick it by boiler type, pick a condensing boiler or a big fire tube boiler, whatever I want to pick. And I got other types of heat sources as well, right? Heat exchangers I could pick from over here. Then the next section of stuff over here are different chillers that I can pick, right? So air-cooled chillers, water-cooled chillers, dry coolers, and then a heat pump chiller if I want to do that. Then I got some stuff that goes along with that, cooling towers, and various accessories. Then I got all my different types of pumps and piping accessories, so pumps, expansion tanks, air separators, and hydraulic separators would be the types of things you'd see in that green section of icons. Then I got some more specialty things here, like a glycol feeder system, chemical feeder if it's like a cooling tower type application, some buffering tanks for chillers and boilers, some stuff like that, an indirect tank for domestic. And each one of those, there's a drop down, and I could pick, what kind I'm going to be using for my system. I got some geothermal options I can add here. Like I said, it's not going to do the geothermal loop for you, but it'll put the equipment on there and do all of the indoor side of it, if you want to think of it that way. Then I got some generic stuff over here for different types of fan coils and loads. The red and blue icon means something that does both heating and cooling. So you're going to find fan coils as a common choice in there, amongst other stuff. Radiant system could be heating and cooling. Then I got the ones that are just red. If I want to do a heating only item, I can do that. And if I want to do a cooling only item, I can do that. And then I got some specific types of fan coils for ducted and ductless and so forth. So those are kind of how the icons work along the bottom there. Let me just make sure we don't have any questions so far. So far, we're good. All right, so I'm going to start with the loads and work my way backwards. I'm going to do that, and now I'm going to pick for right now some fan coils, and I'm just going to do heating only at the moment. We can talk about cooling systems in a little bit. I'll just do heating only fan coils, and I'll start with the loads there. And once I tell it all the loads of all my fan coil zones, it'll size my boilers and things like that for me. So that's kind of one of the reasons to start there. So I'm going to go over to fan coils. I could pick, or heating loads, and I could pick what type I want. I could pick a coil and an air handler. I could pick a fan coil, thin tube, heat pump, radiator, radiant floor, snow melt system, chill beam, whatever I want. That's based on terminal type. Or I could pick something that's a process, like a swimming pool, for example, right, if I'm going to heat up a pool. Or I can pick entire buildings, right? If I want to draw a campus out, I could do that with this software. I could put in, the office and the laboratory and whatever else they got, industrial plant, hospital, mix it all together, dorm building, etc. But I'm going to keep it simple, and we're just going to do a bunch of fan coils right now. So I'm going to pick a fan coil. Right now it's heating only. You know what, actually, we'll do a heating and cooling one. right? And then later on we can always decide what we want it to be and switch it around. So there's my heating fan coil. I drop it on the drawing. If I double click on that guy, I can go through and change properties for that, right? So here's my heating properties. I can put in his BTUs. Let's just say it's, I don't know, 30,000 BTUs of heating, right? If I have cooling, I can do that. If I don't have cooling, I could just turn the cooling section off, and now it's heating only. But I'll leave it on there for right now. What the hell? And we'll say that it's 20,000 BTUs of cooling for that little fan coil, right? On the heating and cooling, I can specify the temperatures. So right now it's defaulting to a delta T of 20 for the heating and 10 for cooling. And I can do that if I want to. I could also go in and specify the exact temperature that I want. And then it asks me, do I know what I'm doing, or if I'm an idiot. I am an idiot, but I'm going to go ahead and say that I know what I'm doing. And let's say that I got 180 coming to my fan coil and 160 coming back. That's a typical fan coil design. I could certainly do it with lower water temperature or even slightly higher if I wanted to, but I'll do it that way because it's kind of traditional for right now. Same thing on the cooling side. I can change it if I want to. Ask me if I know what I'm doing. Sure. Right, and I'll say I'm going to give you 4456, which is a typical chilled water system. Right, and you can change those on a project-by-project basis. Now, I don't have to go in and tell it the GPM that I have, because if I tell it the BTUs and I tell it the water temperature, it's going to calculate the GPM for me. So I can leave that alone, and it'll calculate the GPM for me on my schedule. If it's an existing system and I already got a certain flow going there, I could check this box and go ahead and demand a certain GPM, but then it's going to tell me what water temperatures I'm going to end up getting because of that. Right, so I'm going to leave it like I had it before where I picked the water temp. Head loss. If I know the fan coil that I want to use, I can put the pressure drop of that fan coil in there. If I'm just doing a schematic just to show someone what it's going to look like, it doesn't really matter. I'm just drawing it out. But if I want to actually size my pumping system, I got to tell it the head loss of the fan coil. So initially I'm going to leave it at the default, but then once I get to the point of picking my specific brand and model of fan coil, this is something I could tweak later on to help me more finely tune in my pump size. Right, so that's my basic data there. And if I go down the left side here, I'll go through some of these, but you can change some of these things. It's going to automatically tag it with this tagging scheme. So the next one I plop down will automatically be -2, -3, -4. If I don't like that, I can name it whatever I want. Right, so I can change these names to be, whatever, dorm room number 1, dorm room number 2. I can make it whatever I want, and I can also specify a location for each one. I'm just going to let it do the automatic tagging for right now. Some of the other things that I can go through and tweak on here. Under Hydronic, I could tell it if I have a straight water system or a glycol system. Now, what I normally do is I don't do that at the fan coil level. If I'm going to have a glycol in this loop, like say it's a chill water system and I'm going to have 30% glycol, 40% glycol, whatever it is, I usually will tell it nothing at the fan coils, and later on when it plops the chiller down on there, I'll go in and tell the chiller what glycol percent it has, and then that'll automatically push that to any devices that are on the same hydronic loop, and it'll automatically go and update all my fan coils for me. So it saves a little bit of time that way. So I'll typically do that at the chiller level instead of the fan coil level. Right, so there's just different things you can tweak on here. If I want to pick a particular manufacturer and specify the brand name on here, right, brand number A, right, I could do that. If I know exactly what it's going to be, if I'm going to use a first company fan coil, fine, I could do that. If it's multi-aqua, I can do that. And that'll end up populating on there. I'm just going to go ahead and put brand A in there just so you can kind of see what it looks like. And then we'll put in here model ABC, right, so that way it'll show up on stuff later down the road. If I know the dimensions of the unit, I can put that in there, and that'll show up on my schedule. For today's purposes, it doesn't really matter. I'm not trying to jam it in a specific spot, so I don't really care today. But on a real job, you obviously would. I want all this stuff to show up on my reports. That's why I changed those defaults earlier, right? So all that's good. And if I had specific costs associated with buying that fan coil, I could plug them in here if I'm doing the cost analysis part. If I'm not, I would just leave that alone. So you could do that basically in 10 seconds by just filling out this screen and being done. Or if you want to get anally detailed, you can go through and fill more stuff out. Right, so what it does is it threw on there 30,000 BTUs heating, 20,000 BTUs cooling. Because I have those numbers, it's telling me I need basically 3 GPM of flow on each of those 2 fluids. Here's my fluid temperatures for each one of them, boom, boom, boom. And it kind of put that on there for me. Now I could drop other fan coils or other terminals on here, or if they're all going to be kind of similar, I can highlight that guy by clicking my mouse on him, and then I can do the Control-C to copy, like you would with any Windows program, or I can right-click on it and choose Copy. And then I can paste this guy wherever I want it by hitting Control-V, right? Or I can right-click and choose the paste and drop them wherever I want as well. right? So if there's 3 fan coils, boom, boom, boom. Now this one might be slightly different. I could just go on here and say, oh yeah, this guy's actually 50,000 BTUs, and he's 35,000 cooling. Great. I can go tweak that guy, right? And this one over here is whatever, something else. This guy's 100,000 BTUs heating, right? And maybe he's I don't know, 80,000 cooling, whatever it ends up being, right? And say okay. So you see, I end up with different heating cooling BTUs and different flow rates: 3 GPM, 5 or 6 GPM, 10 and 13 GPM for heating and cooling for those specific BTUs, right? The GPM that I need is a function of the BTUs that I want and the temperature differential that I have. So that's kind of how the GPM is getting calculated. Same thing you would do by hand. The computer's just doing it for you. Now, if I want to make it look a little prettier, what I can do is draw my mouse or box around these guys and then right-click on it, and then I can pick some things on here like space evenly on the left and right. Space evenly on top to bottom. So these guys are separated by the same distance. And then I can pick them to align all to the left, for example, so they look a little bit cleaner in my drawing, so as opposed to a giant hodgepodge. Now what I normally do is I draw a piping loop around this building, similar to the way that I want it to be laid out, and then I'll start plopping other things on there, like the boiler and the chiller and the expansion tank and that kind of stuff, and let them get auto-sized onto the system. So to draw the piping, it's this little squiggly icon up here that looks like a little, I don't even know what it looks like. It's like a pipe, I guess. So click on that, and now your mouse becomes a pipe drawer. The way I like to do it is basically the way the water flow is going to run around the building. So right here, I might take off of my return water off of my coil, and I'll draw my loop around. I'm just going to draw, I don't know what it's going to look like right now. I'm just going to draw one that makes some space. Everywhere I click my mouse ends up becoming a joint or a connection, right? Or an elbow or a connection. So I'm just going to draw this loop, and we can make it different shaped later if we need to. Right, so there's my loop all the way around this building from my last fan coil back to my boiler chiller plant over here on the right. And I'm going to tap these other fan coils in as well. So every time I click my mouse, it makes a connection right there to that pipe. And I'll dump the return there, and the supply will come back to that guy. Right, same with this guy. Boom, boom, boom. Right, so now my piping is connected. If I want to go back to my regular mouse, I can just hit escape, and my mouse goes back to the normal type guy. Right, so you see I got my we'll call it right now my hot water temperature. It's going to come over here, hit the first fan coil, return back to the first one. So this is going to be a direct return system, the way I drew it. You could also draw a reverse return or any schematic that you want to have. All right, now I'm going to need to get some other items on here, right? I need a boiler. So I'm going to pick a generic boiler, and for right now I'm just going to pick a douche draft cast iron boiler. I'm going to plop this guy down on the drawing over here. And it may or may not fit exactly with the way that I want it to fit, so I might have to change my piping a little bit, right? So it did connect it automatically there and automatically up here, but it does look kind of weird, right? So I may click on this piece of pipe and drag it over that way, and then click on this one and drag it up that way, so it doesn't look so hokey on there, right? I could have put my boiler down first and then connected it, but I just wanted you to see how it looks when you automatically drop the boiler in. So I dropped this boiler in there. It's telling me I need a 180,000 BTU boiler. That's because he went over here and added up my fan coils, 30, 50, and 100. That's 180,000. And for 3 fan coils, you probably would size the boiler for the full load. If you had, 100 fan coils, I'm probably going to take a diversity credit based on my load calculations, and I can put that diversity factor into my boiler, if you will. And I'll show you how to do that here in a second. Actually, we can go and do the boiler settings right now. So I can either double-click on the boiler, or I can right-click on it and pick properties either way. And it'll give me some data very similar to the fan coil data I had here. So this particular boiler is only going to be used for heating. If it was going to be used for cooling, we probably wouldn't have called it a boiler. We would have called it a geo unit or a heat pump or something like that, somebody who can make both hot and cold. And then I would have both of these available to me. But in my case, I'm just going to leave it alone. It's only going to be used in the heating season. And here's where I can put my diversity factor in. If my load calcs basically worked out that based on the time of year, I only need to have my boiler be sized for 78% of the load, I can do that, right? And then instead of a 180,000 BTU boiler, I'm going to get a 140,000 BTU boiler. And that's totally normal, like you would do on any project. In my case, I only got 3 fan coils, so in that case, it's such a small system, I'm going to size it for 100%, right? Because I picked a cast iron boiler, it's defaulting to 80% efficiency. If I were to pick a condensing boiler, then I would have a higher efficiency and so forth down the line. And because it's 180,000 is what I need, at 80% efficient, it's going to specify in my spec later that prints out that I need a 225,000 BTU input boiler. And he's going to make 180-degree water. There's his flow. If I know the brand of boiler I want and his pressure drop, I can put that in here. Right now I haven't decided that, so I'm just going to keep the default of 2 feet ahead in there. And then I can go down the line here and change stuff, right? Boiler 1 is going to be called B-1. If I want to go with a different scheme, I can just check the box and I can punch that in, right? And I can go through and tweak some of the values like I did on the other products. There's not really any that I need to tweak in this particular case. Everything's going to be pretty normal here. So I don't really have to mess with anything really in that case. If I'm going to do the costing thing, way down here, I can put the cost in for the actual boiler of that size and type. All right, so 180,000 BTUs, 18 GPM, make me 180-degree water, 160 comes back. A pretty normal little hydronic system. Right, now I need to plop on some of the required items that I'm going to have, right? So one thing I'm going to need is a pump, right? And if I click on the pump choices here, these are the different ones that are available to me. For something this small, it's going to be a small pump, which we actually generally just call a circulator at that point, although technically for a closed-loop system, everything's a circulator. But I know what they mean on here by circulator, and that means it's my smaller pump style. So it's going to give me a little bit different pump here. And that guy's really tiny, but maybe I'll do just a bigger one just so you can see what it looks like. Right? If I did a big frame-mounted pump, it would look like that, which obviously is too much for this little tiny system. Right? I kind of have to know the kind of units that I want. So I got different choices here. Here's a vertical inline pump, right? So maybe I'll plop that one on here for today's purposes. Oops, I lost my my cursor there. Let me check and see if we've got any questions right now too. Looks like we're doing good on questions. If you guys have questions as we're going, just type them in that question chat box down at the bottom, and I'll try to address questions as they come up with you guys. So we were dropping a pump on here, right? So let's just do this vertical inline pump, right? And when I drop this pump on, right now my pump arrows are going left to right. When I drop him on here, he's going to automatically correct himself. And if I drop him on top of my piping line, he's going to automatically connect himself. Right? So now my arrow is switched to the right. He automatically connected himself. If for some reason I didn't drop him on here very cleanly, let me zoom it up so you can see a little bit better too. If I didn't drop him on here very cleanly, then my GPM would not have calculated for me. So he's telling me I need 18.5 GPM at 11 feet of head, right? So where did that come from? The 18 GPM comes from the sum of all my GPMs on this loop. So 3, 6, and 13. There's basically my 18 GPM. The feet of head comes from the pressure drops. So right now I got the pressure drops that were defaulted in each of these fan coils, which is 5 feet. I think it was 5 feet, wasn't it? 5 feet. And the pressure drop of the boiler, whatever that was, adding all that up to get to my 11 feet of pressure drop. But right now I didn't tell it how much pipe I had, did I? So I do need to specify the lengths of pipe. And if you're going to end up printing this drawing showing the links on it, then you need to put every single length in for every single segment. However, if you just want to get the pump size correctly and you're not going to print a drawing with links, you can kind of put all the links in one spot if you want to. So right here I'll click on this pipe, and you can see it automatically knows I want to put the length in. It's got some default values for the pipe and velocities and so forth that I'm using for that particular type of pipe. It's telling me I'm going to need a 1.5-inch diameter pipe because of the GPM that I have, but I didn't tell it any length, right? So this piece of pipe, I'm going to tell it it's 50 feet, right? And as I put these in, it's going to start changing the head of my pump. So this one over here, I'm going to tell it it's just 10 feet, right? Because that's just right there from the pump to the boiler, right? This one over here, maybe this one's 50 feet, right? And if I want to come do these little segments over here, maybe that's 2 feet, right? Some of these aren't, going to be anally unnecessary, but maybe that's 10 feet. So I go punch all these links in, and I think you get the idea. It starts tweaking the feet that I required for the pump. GPM doesn't change, right? Because GPM is a function of the BTUs that I want. The feet of head of the pump is a function of the restriction of the piping system and any of the loads, right? So the fan coil pressure drop and all the piping pressure drop. So that's where that's coming from right there. Right, so that's where I drop my pump on, right? I'm going to need an expansion tank system. So I come over here to expansion tanks. There's all kinds of ones that I can pick: vertical, horizontal, diaphragm, bladder, floor mounted, hung, whatever. You can even do full and partial expansion, although I have no idea why you would buy a partial expansion tank. It seems like you got to buy a bigger tank to get less capacity, which seems weird to me, but I'm sure there's a reason for it. This is a little system here, so I'm just going to pick a diaphragm tank and drop it on here. I'm going to put him upstream of the pump, right, because we always pump away from the expansion system. That's Hydronics 101, if you will. So I'm going to drop him on to this guy right here, and I cut my drawing off, which doesn't help me any. So let me lower these down so I can see a little bit better here. All right, now I can see it a little bit better. So I dropped him on here, and he's telling me I need an 11-gallon tank. How does he know that I need an 11-gallon tank? Well, that's a function of the temperature delta T, right? I got 180 degree supply, and it could get cooled down. Well, it's 180 to 160, but it's going to get cooled down to something lower than that when the system's off, like 70 degrees, right? So I got this 110 degree potential delta T that I have to handle with my expansion system, and I know the length of all the piping, and I know the volume of water in all these components because there was a default volume for each one of these that I can go and adjust if I want. So based on all of that, I know how much water it holds. I know the temperature delta T. That's how I size my expansion tank. So it did the math for me. So all these things, where it's sizing the boiler, the pump, or the expansion tank, it's just doing the math for us, right? It doesn't change the fact that I need to know what these things are and how they work. So it's just a computer software, right? So it's garbage in, garbage out. If I don't give it any pipe lengths, it's going to change the storage capacity I need. If I go in and change this from 50 feet to 500 feet, well, guess what? Now I need a bigger tank, right? 14 gallons instead of 11 gallons, right? So the lengths affect both the feet of head of the pump as well as the capacity of the expansion tank. I'll put that back at 50 so it's a little bit normal looking system. I'm going to need an air separating system, right? So let's pick the inline one for that. See if I can drop him in right on top of here. I did not drop him correctly because you can see he did not connect my pipe. Now he's stuck underneath there. Okay, you know what? I'm just going to delete all those. It'll be easier to plop them back on. Give me my air separator. Give me the expansion tank. All right, so air separator, expansion tank, pump, or my boiler out to my system. That's the kind of the basic things that I would need for the system to function, you know, on a basic level. If I go over to the hydronic pipe accessories, I can pick any type of detailed stuff I want. So if I want to put temperature gauges on my boiler, I can come over here and I can pick a temperature gauge, and show it on my drawing. Right? And then if I show it on here, it's going to show up on my schedule as well. If I don't like the way the naming system works, that's fine. I can put on here, you know, whatever you want to call it, leaving water temperature. Right? And then it'll say leaving water temperature on the drawing. Right? And I can put one on the supply, and I can put one on every fan coil if I really want to, although I probably wouldn't do that. I can put any of those kind of accessories on there. I want to show it connected to the building automation system. I can pick the one with the squiggly line on it. All right, and then it'll link up to the building automation system application if I want. So I can show it as a BAS sensor with electrical wiring connected to it, or I can just show it as a regular, you know, gauge type sensor. Ones that are going to come up a little more often are the valves. So over here on the left side, I got all these different valve choices, right? So one of them I'm going to pick here is a 2A control valve. And for this little type system, I would probably have a ball valve, right? And I can drop him on each one of these fan coils. And then those will show up on my schedule, sized for the GPM loads that I have for these guys. So here, we'll do it that way. We'll put 2As on these guys, and then I'll put a 3-way on this other one just so you can see a 3-way. And then right now, you can see what happened. They made that little dotted line. Whenever it makes a dotted line anywhere on your drawing, that means the software has no idea what the hell it is you're trying to tell it to pipe. Something doesn't look right. In this case, it's saying you got a 3-way valve there and you only got 2 pipes connecting to it. What are you doing, Ryan? So I know I got to go grab this little squiggly line and connect that pipe to something. Boom. My bypass line is now in. Now my 3-way valve makes sense, right? 3-way valve means I got 3 pipe connections. In this particular case, it means I got 2 in and 1 out. It's a mixing valve. If I put it on the other pipe, it would have been a diverting valve. But it'll show up on my drawing that way, on my schedule report that way. So let's look at some of the outputs on this guy for this basic system that we did. So I want to save it. Right, and I'm just going to save it as project 1 on my desktop for now. Right, so then if I go to File, I can pick Open Coordination Files and pick what I want to open. So let me open up the equipment schedule in an Excel spreadsheet. And depending on how much stuff you have drawn, this may take, you know, 30 seconds to a minute, depending on what you got on here. So it shows me my first page of my schedule, and down on the bottom, I got all my different Excel tabs that I can use to see all my different components. For this system, it's basically one thing on each because it's so small, but on larger systems, it's nice having a whole list of all my boilers, all my fan coils, all my valves, all that stuff. So here's the name of my project, test, located at Webinar City, right? My outside conditions that I based it on. If I click on the next one, there's the air separator. It doesn't have a model of manufacturer in there. There's a way for that to auto-populate, in which case it generally populates with Takeo stuff, depending on the product. But in my case, I didn't tell it to auto-populate, so it didn't do that. I'll show you that in a second. But I could go in here and type in whatever I want. So I could type in, manufacturer XYZ and their model ABC. That's fine, right? And where is this going to be located? It's going to be located back in the boiler room or whatever. I can populate that stuff as I see fit. What it does for me auto-population-wise is tells me how it's going to be sized. Well, the air separator's got to handle 18 GPM of standard water, meaning no glycol, and there's the pressure drop that I think it's going to have, right? And if it's going to be higher, I can tweak that if I need to. Same thing with every other component. If I go to the boiler one, right? So it didn't give me a boiler make and model on here because I didn't tell it to do that, but I can auto-populate, or I can manually populate that if I want. So this is going to be a Utica MGB, what do we say, 225 or whatever, because I need 225,000 BTUs. And I don't even know if there is a Utica 225. It may end up being a 250 or 299 or 200 or whatever. I'm just making it up for right now. Cast iron, induced fan in this case, natural gas. Here's my input. Here's my output. There's the flow rate I'm expecting. There's my water temperatures, and so forth down the line. So this can basically put onto somebody's schedule. Same thing for every component. Expansion tank, how big does it need to be? Basically 12 gallons, right? I'm going to operate at 12 PSI. If I need something different, that's fine. I can specify that. But for this little system, 12 PSI is going to be sufficient, right? Here's my loads. So in this case, there were fan coils. Remember I put in there before, I typed in brand A, model ABC, right? It's going to populate that for me on my schedule. So if I do that in my drawing, it's going to populate on my schedule for me. There's my three sizes, right? The heating and cooling coils of each one. I never drew the chiller system in, but I would draw that in next on my drawing. My water temperatures that I'm expecting, so forth. The pumps, in this case there's only one right now, but there's my flow rate and head, and the type of pump that I want. I can type the manufacturer in as I want. And then my last schedules here are my valves. There's my two-way valves, right? So it lists out all your valves for all your fan coils. In my case, there's only two. And what they're made out of, so they're ball valves made out of bronze. If I had some specialty need, I wanted them out of stainless steel, I could have picked that, or I could have retyped it in over here. Either way, if I want to make it two position instead of modulating, I could change that right here or in the drawing, right? So everything's kind of editable. It shows me my flow rate, my head loss, and my CV for the valve. So the CV is already calculated for your controls guy. So there's less math to be done, if you will. And then my last one on the bottom is my three-way control valve. Right, I only had one of those in that case. Right, so that's kind of the basic stuff based on this drawing. There are other output reports you can do as well. I won't go through each one in pain detail, but I'll just show you them real quick. There's a detailed report, which is kind of like that equipment schedule, but it's got more meat to it, if you will. Let's see if we can zoom it up some. Right, so not only does it tell me the stuff that I just read off to you there, but it also goes through the individual specs for each thing that I picked. So air separator, and it's alphabetical, air separator, boiler, my fan coils, my expansion tank. So it's got, line item by line item details of each one if I want to see all that stuff. I could also do a bill of materials, right? So if I'm on the contractor side, this is what I can use to order my materials based on. If I tell it all the links of pipe that I need and all the devices I want, there's no reason I can't just print this off and hand it to the guy that orders my equipment, right, at my shop. So tell me how many air separators I need to buy and what size they're going to be, blah, blah, blah. Same with the boiler. What size do I need? How many do I need? All my pipe, right? Which size pipe do I need? I got to buy some 1.5, 1 1/4, and 1 inch pipe for this project. Actually, I just need 1.5 and 1 inch. There is no 1 1/4. Well, that's because I didn't put all my links in. If I put all my links in instead of just showing you if I actually did it, then I wouldn't end up with some 0 inch pipe, which is very hard to manufacture, by the way. And I wouldn't have had a quantity of none for the 1.25 inches. So those would have been populated if I actually punched the links in for every piping segment like I should have. And then the costs will only populate if you chose to put costs in. If you didn't, that's fine. You can just ignore that piece of it for right now, and your guy would just see all the quantities that he needs to buy of everything else. All right, so then the next report that you can spit out of here is a control schedule if you were using that feature of the software. Right, so it'll list out all the stuff that the controls guy needs to be thinking about. It may not be exactly what your project needs. It's going to be close. right? And everybody does their controls a little bit differently. So here it's telling me all the stuff I need for my boiler. If I'm going to put a control system on the boiler, right, I need to have the return sensor, the supply sensor. I need to have start, stop. I need to have status. But the rest of the stuff probably isn't going to be on my building automation system, right? It's probably there for safety reasons, but not on building automation. So if I'm going to give this to my BS guy, I'm going to have to tell him which stuff I want him to do and which stuff's going to come in the boiler and so forth. Same thing with the pump. I'm going to have pump, start, stop, and a status. I may or may not have a VFD on the pump. If I do, that's going to add some additional points that I need. And it's going to tell me on here whether it's a discrete or analog point, whether it's input or output. So I got some additional info there. And then the valves that are needed, right, for this system. So those are some of the additional reports that you can run on this guy. The other thing that you can do is, if you have the full version of the software that you buy, you can import this directly to AutoCAD. If you're using the free version like I am, you can't directly import it into AutoCAD, but you could throw this drawing on top of your AutoCAD drawing. Right? So if I wanted to do that, I could highlight everything on this drawing, right, and then press Control-C, which is my copy function, and go to my AutoCAD or wherever I'm going to. Just like I put these drawings on this PowerPoint presentation, right, I can plop those down anywhere, on any program, including AutoCAD, right? Paste that on there. Now that drawing is going to be on that. Probably should have gave you a new slide so you can actually see what it looked like. Right, so I'm going to put on a blank slide. Right, so I plopped it on this slide, and then when I expand it up, there it is on there, right? So I can drop that into AutoCAD as a picture, if you will, but not necessarily line segment editable unless I have the full version. Other stuff I can do when I highlight everything on here is I can right-click on it, and I can add different annotations on here. So under piping annotations, if I want to show the diameter of every single pipe on the drawing, I can click that. Now it shows it. So I got 1.5 inch there, 1.5 inches, pretty much on my whole piping system until I get down to my loads. 1.5 on that first big load. This guy's a little bit smaller. He's only 1 inch, right? In between those two, it's 1 1/4. It's all a function of the GPM that I'm asking for, right? So it's sizing the pipe for me, and that's how it knew what to put on the bill of materials as well. Other stuff I could put on there, if I don't want the piping annotations, I could take those back off, or I could leave them on. I could also add on their flow rates, temperatures, things like that. For this one, the temperature is 180 going out, 160 coming back, so I don't need to detail that. But if I had a different type of system with multiple loads, like domestic was this temperature, radiant was that temperature, snowmelt was that temperature, then I probably would want to show the different temperatures on my drawing. But I could pick which things get shown, and I could turn them on and off as I see fit for that particular item. So if I want to turn those temperatures back off, I just turn them back off like that. So right-clicking on it, it's got a few additional options where I can rotate stuff. I can do a mirror image if that fan coil needs to have its hydronic piping connections on the other side. I can click on the fan coil. I can go to mirror image, flip them left to right. Now his piping's on this side for some. If I had it set up that way, right? He's going to be like this or something like that, right? So I can do that if I need to make everything work out. I'm going to undo that because I don't want that in my drawing, but I have the ability to do that. Let me look over at the question box and see if anybody's typed anything in here. All right, I think I'm good on the questions. Nobody's got any questions right now. Okay, let me show you a few more things, and then if you got any more questions, let me know. So a lot of times, like this is a boiler plant, I don't have a chiller on here yet, so I would need to add a chiller on here. And I didn't give myself a lot of room to do that right now, but I'm just going to squeeze one in anyway. This is such a small system, it's definitely going to be an air-cooled chiller. I can pick a generic one, or in this case, I know that I'm going to need a fairly small chiller, right? I got 80, 100, 135,000 BTUs. I got like a 10-ton chiller. I know that Multi-Aqua makes a 10-ton chiller, so I could pick theirs if I wanted to. They make one with a pump in it or one without. Obviously, in my case, I would need one without. Or I can go to the generic one and do it that way. I could pick it by compressor type. For 10 tons, I know I'm going to be working with a scroll compressor because nobody makes, a 10-ton centrifugal. And nobody makes an air-cooled centrifugal either, right? So I'm dropping my chiller on here. It's just a generic drawing. It doesn't have any particular look and feel to it. And then depending on whether this is going to be a 4-pipe system or a 2-pipe system, that kind of dictates how I end up drawing things down the road, right? And if I looked at some of these properties on my unit, I could see I had this designed for 4456 on my fan coils. So that's what my chiller is going to end up wanting to do as well. So I'm just going to squeeze them in here right now, even though I didn't give myself a lot of room to do that. We'll just make it work for today's purposes. And I'll actually just mirror image him. So what's the best way to squeeze him in here in parallel with this guy? So my return water coming back is right here. My supply water. Alright, so now this boiler and chiller are in parallel with each other. So they're doing things side by side here. My chiller just sized himself, right? And he picked up the water temperatures from the fan coils. I already told the fan coils I wanted them to work with 44, 56, right? And I told the loads 20, 35, and 80,000 BTUs. Those loads add up to be 135,000, which is an 11-ton machine, right? If I change something, right? If I go in here and this is no longer an 80,000 BTU load, it's only 70,000, fine, right? So now my machine went from 11.3 to 10.4, right? So as I change loads, the chiller will automatically resize. Now this is an air-cooled chiller, and my building was in Chicago, if you recall, right? That was my default city location. So when I go to the properties of this chiller, one of the things I do want to go in and change under Hydronic is I'm going to put glycol in there. I'm not going to have an air-cooled chiller sitting outside in Chicago without glycol in it, right? So in my case, I'm going to use propylene glycol because that's what we generally use. I'm going to leave it at 30%. Some of you guys may prefer 40. Depends on whether you want to run the chiller in the winter or whether you want the chiller just not to be frozen while it's sitting there, right? Because I can let it get a little slushy if I'm not trying to pump it. If I'm trying to pump it and run it, then I got to think about that a little differently. A 10-ton chiller is not going to hold 500 gallons. And this is true of all the fan coils, chillers, boilers, and everything. They have a default in the program of their fluid volume, but it's the same regardless of the size. If I put in a 1,000-ton chiller or a 10-ton, it's always going to say 500 gallons on here. So I want to go in and correct that and make it for whatever my machine is really going to be, or at least make it close. But I know a 10-ton chiller is not going to have 500 gallons of water in it, right? So I don't know what that machine holds, but for sake of argument, I'm going to go ahead and put in, 5 gallons of water, right, and say okay to that. It's asking if I want to add a glycol feed system. I'm going to say no for today's purposes, but I could definitely add that in if I wanted to. Do you want to disable asking about that in the future? No, I don't want to disable. I like you reminding me, so I'm going to go ahead and let that happen. Right, so sometimes it'll prompt you for accessories that might frequently go with another thing. It doesn't happen on too many accessories, but it happens occasionally. I think if you put a water-cooled chiller in, I think it also asks you if you want to put a cooling tower or a dry cooler in, that kind of stuff. Right, I may put a buffer tank on here. Right, this system may have certain fluid volume that's needed from the chiller manufacturer, so it may require me to put a buffer tank on here. So right here, holding storage tank, closed circuit. For the little guy of that size, I'd probably have a horizontal tank, although it wouldn't be physically that big probably. I could drop him on there. Right now he says he's 0 gallons because he has no idea how he needs to size himself. Right, so I got to size that one generally myself. So how big does it need to be? I can base it on 3 gallons per ton. That's actually should have sized on that because it was already turned on. Why didn't it do that? Oh, there you go. I didn't drop it on the lines. Okay, so because it was defaulted 3 gallons per ton, it decided to put in a 56-gallon tank. If I had a different manufacturer and they needed 4 gallons per ton, I could do it that way, right? It knows the tonnage of the system, so it can do the math for me. If I want to size it differently, like I know I just want to put in a 45-gallon tank, fine, 45-gallon tank. In this case, why did I go to 50? Oh, saying I already have a 45, okay. Well, it's probably better to do it that way anyway. So other stuff that you can draw on here, I won't go through every one in detail. I'll just show you what some of them look like, right? If I want to pick different types of loads, right? Like I want to come in here and put in a radiant floor, it would look like that. It's not going to do the radiant floor loop design for me, but it'll do the distribution side for me, and I could tap that into my system. Well, I'm not going to tap it into the 180-degree water, but I'm not going to do that. That wouldn't make any sense. I'd have to put in a secondary loop and an injection pump, but I could certainly draw that on here as well. Other loads that you might use, right? You may have fin tube baseboard. Looks like that when you draw it on here. Right? I may have a radiant ceiling. I may have a unit here in a warehouse area. Right? There's all kinds of different drawings that you can pick and choose. There's chill beams that are on here, a water heater, indirect water heater tank. Right? I can drop a lot of different stuff on here and connect it in. Of course, I got to think about what's the best way to pipe it in, and does it need a different water temperature, but I can do all that stuff. Same thing on the cooling side. I can throw different loads on here. If I want to put a chilled beam on here, I could put a chill beam on there, right, and tell it the water temperature is going to get. In that case, I would also need a separate piping loop because I couldn't put the 44-degree water to the chill beam, obviously, right? If I want to put a panel radiator on here, I could do that. If I want to throw a heat pump on here, which wouldn't make any sense with a chill water system, but on a regular system, I could do that. If I want to put a coil and an air handler, I could do that, right? So I can drop any of these types of devices on there, whether they are loads or whether they are supply type devices. If you want to put two pumps in parallel, which is a very common question that I get, you can certainly do that. The easiest way for right now is usually put two identical pumps in, right? So I'm going to copy this pump. I'm going to click on it. Let me zoom in so you guys can see it better. Click on it. I'm going to press Control-C, or I can right-click it and go copy. I'm going to paste one right here. Boom. Then I'm going to go grab my piping drawing and connect him in. Boom. Boom. So now it's giving me two identically sized pumps. Both of them sized for 18 or 22 GPM, because that's the cooling's the largest one, 40 feet of head in this particular case. Right, and they're equally sized. And if I'm going to run one as a backup, that's how I would do it. If I'm going to run both of them simultaneously in parallel, right, then what I would need to do is go into these pumps and tell it that you're not handling 100% of the flow, you're handling 50 for both heating and cooling, right, and you're handling 50. Right, and then it would size it like that, and it's going to note on there at 50%, so you remember, oh yeah, I only sized that for half of the flow. So both of these pumps need to run in this particular case if they're both fixed-speed pumps. Right? If I got three of these pumps, which happens sometimes, they want three pumps, and two of them are going to operate, and one of them is a backup. Probably not the best way to draw this, but just gonna jam it in here. Normally, you kind of think about how you wanted to draw it in advance instead of just jamming stuff in like I'm doing now, but this is example purposes, right? So now each one of them is sized for 50% of the flow, right? So two of them are always running in a lead lag control scenario, likely, and then one of them is backup in case one of the first two fails, right? So normally you'd size them each for 50%, but you'd only be running two of them in that scenario. If it bothers me that those guys aren't lined up, and it does bother me, I could highlight all that, and then I could say a line on the right side. I don't want to do that. That was not very helpful. I guess I could have done that before I had lined them up. I could just click on them, the three of them, and now highlight everything. And then I can align them. All right, now they're all in a straight line. I like it better that way. And if it bothers me that that line's there, I can always move it that way, so now you can see the annotations better. All right, so what questions do we have? Let me see. Has anybody got any questions? Greg, let's see. Let's start with the first one. Jason says, how do you show closely spaced tees? All right, so there's a couple things you can do on that one. If you're doing a primary-secondary loop, and let me save that, and let me just open a blank sheet so I can show you that real quick. So if I'm doing a primary-secondary loop, let's say I got a condensing boiler here. There's my condensing boiler, and let's just say I have one terminal to make it easy, right? And I got a piping connection. I'm not even going to put in all the accessories, guys. So don't yell at me when it doesn't have expansion tanks and all that, right? I'm just going to put this guy in here, right? So I could have drawn it like that, which would have been kind of interesting, right? Directly dumping this condensing boiler into here. But more likely, a condensing boiler is going to require primary, secondary. So I'm going to have one loop that just goes out and does my primary right there in the boiler room. That's this guy right here. And by the way, the condensing boiler does show you the condensate line. So you remember you have to connect that to something eventually, right? And then I got my my fan coil, or multiple fan coils in real life, right? They're all going to be over here on their primary loops, or on their secondary loops, excuse me. All right, now I need to connect these two together, right? So there's different ways I could do that. Probably the easier way would have been to draw it like this. And I could have drew my loop like that, right? And right here are my two T's right here. Now, if you actually want to put the T on there, Greg, my T's. All shut-off valves. Where are the T's? Oh, you know why it doesn't show the T? Because they want you to use the Taco Twin T product, which would automatically would have drawn on there. That's why. I turned that feature off. Well, that's how you would do the primary secondary, but it's not actually going to detail the T fitting because I don't have a T fitting available to me. Oh, wait, here we go. Well, that's a Twin T. That's a Taco Twin T, which is what you're asking for, Greg, but it's just a prepackaged product. Looks like that. I could mirror it. If you want to show it that way, you could do it that way instead. I could have done it like that, Greg, and used their product, even if I wasn't going to use it in real life. And then I could hook that T in here. Ah, not there. All right, I could have shown it that way. And that could be two separate T's, or it could be the Taco Twin T, which is a packaged T. All right, let's see the next question. How much does the Pro version cost? I don't know that off the top of my head. It would be on the HVAC Solution website. You can go on there and see what that says. It's probably like $1,700, I think, the last time I looked. If you go on that website, you should be able to go into their products and see what that software package costs. Depends on what you want on it. If you want Revit, it's going to be more. If you don't want Revit, the package is going to be less. I don't see where it says it on here, but somewhere you can click on here enough times. Okay, 1,800. So I said 17. It was off by a little bit. All right, next question. Looks like we got 2 or 3 more, and then we're done. Is there a streamlined way to pipe routing for pressure drop calculations, or do we only have the segment-by-segment method? When you say routing, you want to draw it generically and then have it be piped differently? I'm not sure on that, Bill, how you mean. The pressure drop calculation is based on the length of pipe and the inside surface roughness of the pipe. So I already told it that I was using copper type L, and then I have to tell it the length. Otherwise, it's not going to know the pressure drop. And then I didn't show you on there, but for fittings, it's assuming a default of 50% penalty for fittings, and you can adjust that penalty for the fittings if you want. Bill also asks, and this is the last question, then we're out of time, storage tank volume, did it account for the piping system water volume in its determination? And the answer should be yes. If we go back to that real quick, it was the other drawing though. If we open up that project number 1 drawing, right, that's this tank right here that Bill's talking about, right? So if I were to change the pipe length, I would expect the tank to change, right? So if I go in and tell it to something extreme, like this is a 1,000-foot piece of pipe, and I used to have 56 gallons, it did not change it at all. So to your question, Bill, it should, but it did not change that calculation. So that's an error in their program, and I'll point that out to them. All right, with that, I think that concludes our webinar. If anybody has any further questions, feel free to send me a note, and I'll be happy to try to answer them. I'll put my info back up on the screen as you guys are all logging out there. And thank you guys for